a walkthrough through Lab 8. So Lab 8 is going to be due this week. This week we're going to be focusing on hypothesis testing. Again, going back to testing that we've done before, we're going to look at t-test. So t-test uses means, and basically throughout this we're going to be looking at a lot more ways to test, which side of the tail we're looking at. So for this lab, it's questions 11.8, 11.12, 11.14, and 11.16. So I'm going to go over 8, 12, and 16. 14 is very similar to 12, so just make sure you follow the instructions. Again, this video will be available to you. Okay, so we're going to start with 11.8. So 11.8 is just asking for the confidence limit of individuals who work. So the specific question, I'm just going to pull it up here. So what you want to do is to investigate this problem. A school guidance counselor took a random sample of 200 15-year-old high school students and asked how many hours they work each week. So you want to estimate a 95% confidence interval with the mean amount of time all 15-year-old high school students devote per week to part-time jobs. So we want to see, based on our average, is it in between or outside these two sets of numbers? So the first thing we want to do is calculate the X bar. X bar is just your average. Again, this data set is our average hours worked, gender, and our GPA. So we want to get it for hours. It should be 715. So our confidence limit is going to either fall in between this or outside of this. So we're going to say, is this a good measure or are we off? So next one's going to be standard deviation. This is something you guys should know by now, I hope. You get 1.645. Next one is n. So you can use a count command. And it's also given to you in the problem. If you need it, it's 200. Okay, the next one is t. So we need a t critical value. Now for this, we're going to use the t.inv.2t, so two tails, because again, we're trying to find the confidence interval. It's the lower and upper bound. So just think both sides of the tail, so a two-tail test. Now the probability. The probability is going to be 95%, so you can do 1 minus 0.95 or just 0.05. And degrees of freedom is n. So our n is our degrees of freedom. You should get 1.97. That's what it is going to be for this example. Now our lower confidence limit is the lower bound, upper confidence limit is the upper bound. So for lower confidence limit, we've done this in previous labs, it's going to be your X bar subtracted because it's the lower bound, so it's going to be the left hand side of the test. And it's going to be your critical value multiplied by your standard deviation divided by the square root of your n. Make sure you put your parentheses, and you get something like 6.92. So that's your lower bound. Upper bound, same setup, but the only thing different is you add. So it's your X bar plus your critical value multiplied by your standard deviation divided by the square root of your n. So you should get 7.3795, somewhere around there. So with this isn't all that you need to do. You also need to answer this in words. So I gave you a little template for lab 6. You should use that. So X bar lands in between these two numbers, which is good. So with 95% confidence, we are confident that our data set is accurate, or this claim is justified. So again, make sure you add a little description, answer in terms of the question. So just make sure you look at that. 11-12. Here we're going to start our t-test. So t-test is where we use hypothesis, or we use means for our hypothesis testing. So here we're going to use we're going to calculate a t-stat and also a t-critical value. And we're also going to use our p-value. Okay, another big thing is if I do not give you your alpha, you're always going to assume it's 5%. That's why it's down here. And I'll talk about why this is important. This is something you should have in your notes. It's not important just for this lab, but also for your lecture portion of this class. All right, so in this question, we want to see how many people have watched more than 15 commercials during the Super Bowl in 2001. So each individual is how many commercials they've watched. So first we're going to do is calculate the sample mean equals average. You should get 15. So on average, 15 commercials are watched. Next is standard deviation. And then next is going to be your n. So you can use your count command. You should get 116. Again, your count, standard deviation, average, stuff you should know. T calculated value. So this is where it gets a little tricky. So with this, you want to use your x bar that you calculated or your sample mean, and you're going to use your mean given to you by your claim, so your alternative. So it's going to be equals your x bar, or let's use parentheses. So it's your sample mean subtracted by your claim, and you're going to divide that. Again, use your parentheses, your standard deviation divided by the square root of your n. And you should get a value of 0.5. So we have our t value. Now we're looking at a right-tailed test. So the value you can compare this to is 1.645, 1.96. These are things you can compare this to. So if this is not in the rejection region, you fail to reject. If it's in the rejection region, you reject. So there's two ways to do this. You can use that method by comparing it to your critical value, or you can use your p-value. So sometimes I'll ask you both on the final. Sometimes in your lecture, you'll be asked both. So just make sure you know how to do both. So the t critical value, or your p-value, you want to use a command t dist equals t dot dist, and it's going to be your x, which is your mean, or your t-value, sorry. Your degrees of freedom is going to be your n, and you're going to put true. You hit enter, you should get 0.69, somewhere around there. Now, based on this, I have this little table that you should memorize for the test and your final. It's very helpful. So if your p-value is greater than alpha, which is in this case right here, so 6.9 or 0.69 is greater than 5%, so 69% is much greater than 5%. If it's greater, you fail to reject. If it was less than your alpha, if it's less than 5%, you reject. So again, answer in terms of the question, you either reject or you fail to reject based on this information. So all this is correct. You just need to add your response, and you should be good to go. Again, make sure you understand this, read the textbook, use your resources. 1114 is very similar to this problem. So again, I'll let you guys do that on your own. Okay, 11-16. This is looking at chi-square testing. You're going to use your variance. Variance is really important when we look at, it's just another way of testing and seeing if your data is accurate. So on our last lab, we'll use, or hopefully we get to use Stata. This does it all in one command, but in here, we're going to do it step by step. So our null hypothesis is that our variance equals 18. Our alternative is that it's greater than 18. Our variance is greater than 18. So first, we want to calculate our n. It's given to us. It's 245 in our example. If you don't trust me, use a count code. Now you want to calculate the variance of your sample. So what's the variance of the speeds? You get 22.56. So we want to see if this value is accurate. Can we reject or accept our alternative? So the next thing we need to do is calculate our standard deviation. This is all important for the chi-squared values. So it equals standard deviation you should get 4.75. Now for our chi-squared value. So for this is how you calculate it. It's equals, it's your n multiplied by your variance that you calculated. So just put parentheses, variance you calculated in your sample, divided by the variance from your alternative hypothesis. You should get 307. So this is your calculated value. Now it's a right tail test, so we're going to compare it to our critical value. Our critical value in this case, the formula we're going to use is chi inverse, and our probability is given to us in the equation as well, or in our practice problem. So it's 10%. So you're going to put 0.10 comma, and degrees of freedom is our n. So you should get 273.76. Now what we're going to do is we're going to compare our critical value to our chi-squared value. So 273 is our critical value. It's a right tail test. Anything to the right hand side of this is our rejection region. So you should know that 307 is much greater than 273. So in this case, we are going to reject our null hypothesis and conclude that our variance is greater than 18. So again, the whole goal here is to reject or fail to reject our null or alternative hypothesis. So that's all of Lab 8. Make sure you answer the questions, answer in complete sentences. I am still grading. Again, if you guys have questions, by all means, let me know. I am going to be holding Zoom virtual office hours just so you guys have some time to talk to me if you need it. If not, and you feel comfortable doing this on your own, by all means, go right ahead. If you guys have questions, let me know. But other than that, thank you guys. Hope you guys are doing well. The semester isn't as planned for a lot of people, so we're just working with what we got. If you have trouble, let me know. I'm more than happy to help. All right, thank you guys. I'll see you next week.